Picture this: a strange, elongated object hurtling through the darkness of space at impossible speeds. Not a comet, not an asteroid, something entirely unknown. In 2017, astronomers spotted our solar system's first confirmed visitor from another star system. They named it Oumuamua, Hawaiian for scout. But was it just a passing space rock, or something far more extraordinary? This mysterious traveler defied all expectations. Its bizarre shape, its unexplained acceleration, its silent journey through our cosmic neighborhood. Some scientists believe it could be a fragment from a long-dead world, a frozen relic from the birth of another star. Others dare to suggest something even more incredible. Could Oumuamua be a piece of alien technology, a probe sent to study us, a forgotten artifact drifting between the stars? The debate has divided the scientific community and captured imaginations worldwide. Today, we're diving deep into the heart of this cosmic mystery. We'll examine the shocking theories, the heated arguments, and the unanswered questions that still haunt astronomers. By the end of this journey, you'll see why Oumuamua remains one of space's greatest enigmas, and you just might find yourself questioning everything we thought we knew about our place in the universe. Now let's rewind to the moment this cosmic mystery first appeared on our radar. It was October 2017 when astronomers at the Pan-STARRS telescope in Hawaii spotted something unusual streaking across the night sky. At first glance, it seemed like just another space rock, but something about its movement didn't add up. Unlike the predictable orbits of asteroids and comets in our solar system, this object was racing along at a staggering 186,000 miles per hour, far too fast to be bound by the sun's gravity. What really set Oumuamua apart was its bizarre shape. Most asteroids and comets are roughly round or lumpy, but this visitor was different. Observations suggested it was up to 10 times longer than it was wide, like a cosmic cigar tumbling through space. Even stranger, it lacked the glowing coma and tail that typically mark a comet. Comets light up when sunlight vaporizes their icy surfaces, creating a visible cloud of gas and dust. But Oumuamua stayed eerily dark, reflecting almost no light as it sped past the sun. Then came the real head-scratcher. As it zoomed away from our star, telescopes caught something unexpected. Oumuamua wasn't just coasting. It was accelerating, as if pushed by an invisible force. This wasn't gravity's doing, and it didn't match the behavior of any natural object we'd seen before. Scientists scrambled for answers. Was it venting hidden gas like a comet, or could something else, something far more unusual, be at work? One thing was clear: Oumuamua wasn't just another space rock. It was a messenger from the interstellar void, challenging everything we thought we knew about the objects drifting between the stars. And the deeper astronomers looked, the more questions piled up. Now, let's tackle the big question: was Oumuamua truly an interstellar traveler? Or could it have been a strange outlier from our own solar system? The answer lies in its path. Unlike the elliptical orbits of comets and asteroids tied to the sun's gravity, Oumuamua followed a hyperbolic trajectory, a steep, open curve that meant it wasn't just passing through. It was leaving for good, with no intention of circling back. Speed told the same story. At nearly 200,000 miles per hour, it was moving too fast to be captured by the sun's pull. Compare that to even the quickest objects in our solar system, like Halley's Comet, which maxes out at around 150,000 miles per hour. Oumuamua wasn't just faster, it was in a league of its own. Then there's the matter of its origins. Most solar system objects share a similar chemical fingerprint, forged in the same primordial cloud of dust and gas. But Oumuamua's dark, reddish hue and lack of outgassing didn't match anything we've seen before. It was like finding a stranger's luggage at the airport. Nothing about it fit the local patterns. Even its tumbling motion set it apart. Solar system objects usually spin in predictable ways, shaped by billions of years of collisions and gravitational nudges. Oumuamua, though, tumbled chaotically, as if it had been hurled into space by some violent event far beyond our neighborhood. Put it all together, and the evidence was overwhelming. This wasn't a misplaced rock from our cosmic backyard. Oumuamua was a visitor from another star system, carrying secrets from places we've only dreamed of exploring. And that realization changed everything. Now, let's shift gears to one of the most provocative ideas about Oumuamua, the possibility that it wasn't a natural object at all. Harvard astrophysicist Avi Loeb made headlines when he suggested this interstellar visitor might actually be alien technology. His theory, Oumuamua could have been a light sail, a thin, reflective structure pushed through space by the pressure of starlight, much like a boat's sail catches the wind. Loeb pointed to Oumuamua's unusual acceleration as a key clue. While comets speed up due to outgassing, Oumuamua showed no visible signs of this process. Instead, its motion seemed consistent with something being pushed by sunlight alone, exactly how a light sail would behave. Then there's its bizarre shape. A long, flat object like a pancake or a cigar isn't something nature typically produces, but it's a practical design for an artificial probe meant to glide between stars. Not everyone was convinced, though. Many scientists pushed back, arguing that extraordinary claims require extraordinary evidence, and Oumuamua's oddities could still have natural explanations. Some suggested it might be a rare type of comet with invisible outgassing, or a fragment from a shattered planet. Others criticized Loeb for jumping to conclusions without definitive proof, calling the alien tech idea more science fiction than science. The debate highlights a bigger question: how do we approach the unknown? Loeb's willingness to consider an artificial origin challenges the scientific community to think outside the box. But skeptics argue that without clear signals or debris, it's premature to call Oumuamua anything but a cosmic oddity. One thing's certain: this mystery has forced us to reconsider what might be lurking in the vast darkness between the stars. Now, let's dig deeper into what really set Oumuamua apart: its strange and unexpected acceleration. Most objects in space move predictably under gravity's pull, but Oumuamua didn't follow the rules. As it zoomed away from the sun, it sped up slightly, as if something invisible was giving it an extra push. This kind of behavior isn't unheard of. Comets often accelerate due to outgassing. When sunlight heats a comet's icy surface, gases burst out like steam from a kettle, acting like tiny thrusters. But here's the catch: Oumuamua showed no visible signs of outgassing. No dusty tail, no glowing coma, nothing. So if it wasn't outgassing, what caused that mysterious boost? One possibility is solar radiation pressure, the force of sunlight itself pushing against an object. For something thin and lightweight, like a light sail, this could explain the acceleration without needing gas or dust. But natural objects are rarely that delicate. Unless, of course, Oumuamua was something we've never seen before, maybe a fragment of hydrogen ice, so light that sunlight could nudge it along. Then there's the timing. Oumuamua's acceleration wasn't constant. It varied in ways that didn't neatly match typical comet behavior, adding another layer of intrigue. Scientists scrambled to model it, testing everything from hidden outgassing to exotic materials, but no single explanation fits perfectly. This puzzle is what makes Oumuamua so fascinating. Its acceleration defies easy answers, leaving room for both natural and extraordinary theories. Whether it was an alien light sail riding sunlight or a cosmic iceberg venting invisible gas, one thing's clear: Oumuamua has rewritten the rules on how interstellar visitors behave. But here's another way to look at it. What if Oumuamua wasn't alien technology at all, but something far older and just as extraordinary? Enter the galactic fossil theory. Picture this: a distant planetary system torn apart by gravitational chaos, sending fragments hurtling into the void. Oumuamua could be one of those cosmic leftovers, a shard from a shattered world, drifting for millions of years before crossing our path. Some scientists suggest it might be a rare type of hydrogen iceberg. Imagine a chunk of frozen molecular hydrogen, so light and fragile that sunlight alone could push it along. These icy relics could form in the coldest depths of interstellar space, where temperatures hover just above absolute zero. Over time, radiation might sculpt them into bizarre shapes, like Oumuamua's elongated form. Then there's the tidal disruption idea. If a planet or comet ventured too close to a star, the star's gravity could stretch and shred it, launching debris at incredible speeds. Oumuamua's unusual trajectory and speed fit this scenario neatly. No alien tech, required just the violent, natural forces of the cosmos at work. Of course, hydrogen icebergs and planetary fragments are speculative. We've never directly observed objects like these before, but that's part of what makes Oumuamua so thrilling. It forces us to expand our understanding of what's possible. Whether it's a piece of a long-dead world or a frozen relic from deep space, one thing's certain: Oumuamua challenges us to rethink the stories hidden in the darkness between the stars. And speaking of stories, let's not forget the silence. Despite its mysteries, Oumuamua gave us no radio signals, no flashes of artificial light. Could that quiet be the final clue, proof that we're dealing with nature, not intelligence? Or is there more to this cosmic visitor than we've yet uncovered? Now, let's take a closer look at Oumuamua's shape and color, two of its most puzzling features. Imagine an object shaped like a cigar, nearly 10 times longer than it is wide, tumbling through space. This extreme elongation isn't something we see in typical asteroids or comets, which are usually more lumpy or rounded. So what could explain such a bizarre form? One possibility is that Oumuamua is a fragment from a violent cosmic collision. Picture two massive objects slamming into each other, sending debris flying in all directions. A shard from that explosion could have been stretched and twisted as it hurtled through space, eventually settling into that strange, slender shape. Alternatively, some scientists propose that prolonged exposure to radiation or micrometeorite impacts over millions of years could have slowly sculpted it into this unusual form. Then there's its color, a deep, dark red, almost like a rusty nail. This hue suggests the surface has been bombarded by cosmic rays for eons, altering its chemical makeup. Many natural objects in our solar system share this reddish tint, but Oumuamua's shade is particularly intense. Some researchers argue this points to an organic, rich composition, possibly even complex molecules formed in the cold depths of interstellar space. But here's where things get even more intriguing. Could that sleek, elongated shape and dark red surface hint at something artificial? Proponents of the light sail theory point out that a flat, reflective object would naturally accelerate under sunlight, just as Oumuamua did. Its shape might not be random at all, but engineered for efficiency, and that dark color, it could be a protective coating, shielding delicate technology from the harshness of space. Of course, nature has a way of surprising us. There are plenty of natural processes that could produce an object like Oumuamua without invoking alien engineering. Yet its peculiar features keep the debate alive, whether it's a shattered relic from a distant catastrophe or something far more deliberate. Oumuamua's shape and color remain some of the strongest clues in this cosmic mystery. And as we piece together these clues, another question lingers. Why did Oumuamua stay so silent? No radio signals, no flashes of light. Was its quiet just another sign of a natural object, or is there something we're still missing? As we dig deeper into Oumuamua's mysteries, one question stands out: why didn't it make a sound? Scientists eagerly tuned their radio telescopes, hoping to catch even the faintest whisper of artificial signals from this interstellar visitor. Projects like Breakthrough Listen, designed to scan the cosmos for signs of extraterrestrial intelligence, turned their attention to Oumuamua. But despite their best efforts, the object remained stubbornly silent. Now, you might think that silence means Oumuamua was just a lifeless rock. But here's the twist: absence of radio signals doesn't necessarily rule out the Spycraft theory. Advanced alien technology might operate on principles we don't yet understand, using communication methods far beyond our current detection capabilities. Imagine a probe designed to observe without revealing itself, a cosmic eavesdropper, so to speak. It might not broadcast signals at all, relying instead on stealth to gather information. Another possibility is that Oumuamua simply wasn't active during its brief visit. If it were an alien probe, it might have been dormant, conserving energy for a future mission or waiting for the right conditions to transmit. Or perhaps its signals were too faint or too brief for our instruments to catch. After all, we only had a narrow window to study it before it raced out of range. Projects like Breakthrough Listen highlight just how challenging the search for extraterrestrial intelligence can be. Even with cutting-edge technology, the universe is vast, and signals, whether natural or artificial, can be elusive. Oumuamua's silence leaves the door open for speculation, reminding us that sometimes what we don't hear can be just as intriguing as what we do. And as we ponder the implications of that silence, another interstellar visitor enters the picture, one that couldn't have been more different. Now, let's step back and consider Oumuamua's place in history. Was it really the first interstellar visitor to pass through our solar system, or have others quietly slipped by without us noticing? The truth is, Oumuamua's detection in 2017 marked a turning point in astronomy, the first time we confirmed an object from another star system had entered our cosmic neighborhood. But that doesn't necessarily mean it was the first to arrive. Before Oumuamua, interstellar objects could have zipped past undetected, lost in the vastness of space, or mistaken for ordinary asteroids or comets. Our telescopes simply weren't sharp enough, or our methods refined enough, to spot them. Think of it like trying to find a single grain of sand on a beach. Unless you're looking at just the right moment, it's easy to miss. Then came 2I Borisov, discovered in 2019. Unlike Oumuamua, this second interstellar visitor looked and behaved much more like a typical comet, with a visible tail and outgassing activity. The differences between the two were striking. Oumuamua's strange shape and lack of a coma made it an outlier, while 2I Borisov fit more neatly into our existing understanding of cosmic objects. This raises an intriguing question: why was Oumuamua so different? Was its uniqueness a sign of something artificial, or just a rare but natural variation? The fact that 2I Borisov acted like a textbook comet suggests Oumuamua might have been an exception, not the rule. But exceptions are exactly what scientists live for. They push us to rethink what's possible. What's clear is that Oumuamua opened our eyes to the possibility of interstellar visitors. Now, with better technology and sharper vigilance, astronomers are actively hunting for more. The next one could be just around the corner, and who knows, it might bring even bigger surprises. And speaking of surprises, let's take a closer look at how the scientific community reacted to Oumuamua's mysteries, because not everyone agreed on what it really was. While Oumuamua's strangeness sparked wild theories, most scientists lean toward natural explanations even if they don't have all the answers yet. The leading idea: volatile outgassing. Picture a comet warming up as it nears the sun, releasing gas that acts like a thruster, nudging it off course. Oumuamua's acceleration could have been caused by this, but here's the catch: it didn't show the usual coma or tail. Some researchers suggest it might have expelled invisible gases like hydrogen, leaving no dusty trail behind. Others propose its surface was covered in rare ices that vaporized unevenly, giving it that odd push without the typical comet glow. Then there's tidal disruption, a fancy term for what happens when an object gets too close to a star and gets stretched like cosmic taffy. If Oumuamua was once part of a larger body torn apart by gravity, that could explain its bizarre cigar shape. Imagine a potato tumbling through space, battered by collisions until only a slender shard remains. But critics point out, wouldn't such a violent process leave more debris? And why didn't we see any fragments trailing it? The truth is, both theories have holes. Outgassing doesn't fully account for Oumuamua's extreme brightness variations, and tidal disruption struggles to explain its smooth, steady spin. Some scientists argue we might be missing a key piece of the puzzle, like an exotic type of ice or a formation process we've never observed. What's fascinating is how Oumuamua forces us to question what we think we know. Even the most accepted explanations require tweaks to fit the data, proving space still holds plenty of surprises, and that's the beauty of science. Sometimes the mysteries are just as valuable as the answers. Now, let's weigh these natural possibilities against the far more controversial idea that Oumuamua was something else entirely, a piece of alien technology. Now, let's tackle the big question: was Oumuamua a stroke of cosmic luck or something far more intentional? To figure this out, we turn to two powerful ideas in science: Occam's razor and the Fermi paradox. Occam's razor tells us that when faced with a mystery, the simplest explanation is usually the right one. In Oumuamua's case, that means leaning toward natural causes, like a weirdly shaped comet or a fragment from a shattered planet, rather than jumping straight to alien technology. After all, the universe is full of strange objects we don't fully understand yet. But here's the twist: sometimes, the simplest answer isn't the correct one. If Oumuamua's behavior defies every known natural explanation, could we be missing something? That's where the Fermi paradox comes in. If the universe is so vast and ancient, why haven't we found clear evidence of other civilizations? Some argue Oumuamua might be that evidence, a discarded probe or a derelict spacecraft drifting between stars. But skeptics counter that it's far more likely to be a rare but natural interstellar oddity. After all, we've only just begun spotting these visitors. So, which is it? The numbers aren't on the alien side. Statistically, there are countless more natural objects in space than alien artifacts. Yet, as Avi Loeb famously argued, if we dismiss the possibility entirely, we might miss the one real clue hiding in plain sight. The debate boils down to this: do we assume Oumuamua is just another cosmic quirk, or do we dare consider it might be the first breadcrumb on the trail to discovering we're not alone? Either way, the conversation pushes science forward, because sometimes asking the wildest questions leads to the most groundbreaking answers. Next, let's dive deeper into one of the most intriguing possibilities: what if Oumuamua was a light sail? Now, let's explore one of the most fascinating possibilities. What if Oumuamua wasn't just a space rock, but a piece of advanced alien technology? Specifically, a light sail. Imagine a spacecraft so thin and lightweight that it doesn't need traditional fuel. Instead, it's pushed through the cosmos by the gentle but constant pressure of starlight, like a boat catching the wind. This isn't just science fiction. Right here on Earth, projects like Breakthrough Starshot are already working on similar technology. The idea is to send tiny probes to nearby stars, propelled by powerful lasers pushing on ultra-thin sails. If humans can dream this up, why couldn't another civilization? But here's where it gets tricky. For Oumuamua to be a light sail, it would need to be incredibly thin, maybe just a fraction of a millimeter thick, and made of materials we've never seen in nature. Its unusual acceleration could then be explained by sunlight pushing against it, much like a gust of wind nudging a leaf. Yet, even if this sounds plausible, the challenges are enormous. Interstellar travel is brutally difficult. A light sail would have to survive cosmic radiation, micrometeoroids, and the mind-bending distances between stars. Plus, if Oumuamua was artificial, why didn't it show any signs of activity, like radio signals or course corrections? Still, the idea captivates because it forces us to think bigger. If Oumuamua was a light sail, it might not be a deliberate message, just space junk from a long-dead civilization, drifting silently through the galaxy. Or maybe it was designed to be stealthy, observing without revealing itself. Either way, the light sail hypothesis pushes us to reconsider what's possible. And while the odds may be slim, the mere chance that we're glimpsing someone else's technology is enough to keep scientists and the rest of us wondering. Next, let's examine another compelling theory. Could Oumuamua have been a hydrogen iceberg, a cosmic snowball of the rarest kind? Now, let's shift gears and consider a completely different angle, one that doesn't involve alien technology at all. What if Oumuamua was something far stranger, yet entirely natural? Enter the hydrogen iceberg theory. Picture this: a massive chunk of molecular hydrogen ice floating through the void of space. Unlike the water ice we're familiar with, hydrogen ice forms only in the coldest, most extreme environments, places so frigid that even atoms slow to a near standstill. If Oumuamua was made of this exotic material, it could explain its bizarre acceleration without invoking alien tech. Here's how it works. As Oumuamua neared the sun, the heat would cause its hydrogen ice to vaporize, releasing gas that acted like a natural thruster. This outgassing wouldn't be visible to telescopes, which solves the mystery of why we didn't see a coma or tail. It's a neat explanation, but there's a catch. Hydrogen ice is incredibly fragile. The harsh radiation of interstellar space should have torn it apart long before it reached us. So, could such an object survive a journey across the galaxy? Some scientists think yes, if it was born in the coldest depths of a giant molecular cloud, where temperatures hover just above absolute zero. These cosmic nurseries might occasionally spit out hydrogen icebergs, sending them on lonely voyages through the stars. But the theory isn't without its skeptics. Critics argue that even in the coldest regions of space, hydrogen ice would sublimate too quickly to last millions of years. Others point out that we've never detected anything like this before, making it a speculative solution at best. Still, the hydrogen iceberg idea is fascinating because it challenges our understanding of what's possible in the universe. Whether or not it's the answer, it reminds us that nature is full of surprises, and sometimes the truth is stranger than anything we could invent. Next, we'll look at another lingering mystery: why Oumuamua's departure left scientists scrambling for answers. Now, let's pause for a moment and think about what happened when Oumuamua slipped through our fingers. Astronomers had just begun to unravel its secrets when it raced out of reach, fading into the darkness of space. The frustration was real. Here was an object unlike anything we'd seen before, and it was gone before we could get a closer look. Imagine what we might have learned if we'd had more time. A mission like NASA's upcoming Lucy spacecraft, designed to study distant asteroids, could have intercepted Oumuamua. Equipped with high-resolution cameras and spectrometers, it might have revealed the object's exact composition, settling the debate between hydrogen ice, alien tech, or something else entirely. Or consider the James Webb Space Telescope. If it had been operational at the time, its infrared eyes could have pierced through Oumuamua's dark surface, mapping its chemistry in unprecedented detail. Even a simple radio antenna, like those used in the Breakthrough Listen project, might have detected faint signals, if there were any to hear. But here's the painful truth: by the time we realized how strange Oumuamua was, it was already too far away. Our best telescopes strained to catch glimpses as it became little more than a speck. The lesson: the universe doesn't wait for us to be ready. This missed opportunity sparked a new urgency in astronomy. Scientists are now pushing for faster response systems like the Vera Rubin Observatory, which will scan the skies nightly, ensuring we never overlook another interstellar visitor. Because next time, we might not get a second chance. And speaking of second chances, what if Oumuamua wasn't alone? Up next, we'll explore the discovery of Borisov, another interstellar traveler, but one that played by very different rules. Now, let's shift gears and see how Oumuamua didn't just capture the attention of scientists. It sparked the imagination of storytellers and conspiracy theorists alike. This mysterious visitor became a cultural phenomenon, fueling wild theories and creative interpretations. Almost overnight, Oumuamua became a favorite topic in science fiction. Writers and filmmakers latched onto the idea of an alien probe, spinning tales of interstellar espionage and ancient civilizations. Some novels, like the Oumuamua Incident, imagined it as a derelict starship carrying secrets from a distant world. Others turned it into a cosmic warning, a message in a bottle from a dying alien race. Then there were the conspiracy theories. Online forums buzzed with claims that governments were hiding the truth, that Oumuamua was a reconnaissance drone sent to study Earth. Some even suggested it was part of a larger fleet, lurking just out of sight. While scientists rolled their eyes, these ideas spread like wildfire, showing just how deeply the unknown fascinates us. Podcasts and documentaries jumped in too. Shows like Theories of the Third Kind dedicated entire episodes to Oumuamua, blending real science with speculative fiction. Even mainstream media couldn't resist. Documentaries posed the tantalizing question: what if it really was alien? But perhaps the most telling sign of Oumuamua's impact was how quickly it entered pop culture. Memes compared it to a rogue spaceship from Star Trek or a lost relic from 2001. a space odyssey. It became shorthand for anything mysterious and unexplained, proof that sometimes reality is stranger than fiction. So while scientists debated hydrogen icebergs and light sails, the rest of the world dreamed of something far grander, and that's the magic of Oumuamua. It didn't just challenge our understanding of space. It reminded us how much we love a good mystery. Up next, we'll look at how Oumuamua changed astronomy itself, pushing scientists to rethink how they search for interstellar visitors. Because if one slipped past us, who's to say there aren't more? Now, let's turn our attention to how Oumuamua didn't just spark debate, it revolutionized the way we explore the cosmos. This enigmatic visitor forced astronomers to confront a glaring truth. If something like Oumuamua could slip into our solar system unnoticed, how many others have we missed? The discovery sent shockwaves through the scientific community, exposing gaps in our ability to detect interstellar objects. Before Oumuamua, telescopes weren't specifically designed to hunt for fleeting, fast-moving visitors from beyond our solar system. But suddenly, astronomers realized they needed to adapt, and fast. Enter projects like the Vera Rubin Observatory, set to begin scanning the skies in the next few years. With its massive mirror and ultra-sensitive camera, this telescope is built to catch objects like Oumuamua before they vanish into the void. It's not just about spotting them, it's about tracking them early enough to study their composition, trajectory, and behavior in detail. Other missions are now in the works too. The European Space Agency's Comet Interceptor, for example, is designed to sit in space, waiting for an interstellar visitor to swing by. If one appears, it could launch on short notice to get an up-close look. Imagine the data we could gather if we'd had this ready when Oumuamua flew past. But the biggest shift might be in mindset. Oumuamua taught us that interstellar objects aren't once-in-lifetime anomalies. They're likely passing through all the time. That realization has turned the hunt for them into a top priority, with astronomers refining detection methods and sharing data faster than ever. So while Oumuamua itself may remain a mystery, its legacy is clear. It didn't just challenge our theories, it changed how we search the stars, and with new tools on the horizon, the next visitor might not escape our scrutiny so easily. Coming up, we'll explore whether Oumuamua could ever return, or if another interstellar traveler is already on its way. Because if there's one thing we've learned, it's that the universe loves surprises. Now, let's tackle the big question: could Oumuamua ever come back, or is it gone for good? The truth is, the odds aren't in our favor. Oumuamua's trajectory shows it's on a one-way trip out of our solar system, speeding toward interstellar space at nearly 60,000 miles per hour. At that velocity, even the sun's gravity isn't strong enough to pull it back. But here's the twist: while Oumuamua itself might be lost to us forever, its visit has opened our eyes to the possibility of more interstellar objects passing through. In fact, some estimates suggest there could be thousands of similar objects drifting through our solar system at any given time. The challenge: spotting them before they're already on their way out. So what would it take to actually chase or intercept one of these cosmic visitors? For starters, we'd need early detection, something projects like the Vera Rubin Observatory aim to provide. But even if we spot one in time, the real hurdle is speed. Current spacecraft, like a Parker Solar Probe, can hit impressive velocities, but they're still too slow to catch up to an object like Oumuamua. That's where futuristic ideas come in. Concepts like light sails, powered by lasers from Earth, could theoretically reach speeds fast enough to chase an interstellar object. Projects like Breakthrough Starshot are already exploring this technology, though it's still in its early stages. Another option, positioning probes in strategic orbits, ready to launch at a moment's notice when the next visitor arrives, just like the Comet Interceptor mission plans to do. The bottom line, Oumuamua may never return, but its legacy ensures we won't miss the next one. And with advancing technology, the dream of catching up to an interstellar traveler might not be so far-fetched after all. Up next, we'll dive into some of the wilder theories about Oumuamua, from dark matter fragments to the idea that it might just be space debris from an ancient civilization. Because when it comes to the cosmos, sometimes the truth is stranger than fiction. Now, let's venture into the realm of the truly unconventional, where science meets speculation, and the line between fact and fantasy gets a little blurry. While most researchers stick to natural explanations for Oumuamua's odd behavior, some have proposed theories that sound straight out of a sci-fi blockbuster. Take the dark matter hypothesis, for instance. A handful of theorists have suggested Oumuamua might be a rare chunk of dark matter, the mysterious, invisible substance that makes up most of the universe's mass. The idea, its strange acceleration could have been caused by interactions with dark matter particles, but here's the catch: dark matter doesn't behave like that. It doesn't clump into solid objects, and it certainly doesn't reflect sunlight the way Oumuamua did. Most scientists dismiss this as wishful thinking, a stretch to explain the unexplainable. Then there's the space debris angle, the notion that Oumuamua could be a piece of wreckage from an ancient alien civilization. Picture this, a million-year-old probe, battered by cosmic rays, tumbling through space like interstellar junk mail. It's a fun thought, but the lack of any artificial signals or obvious tech signatures makes it a tough sell. As one astronomer joked, if this is alien garbage, it's the most well-traveled trash in the galaxy. Of course, there's always the possibility Oumuamua was something entirely new, natural phenomenon we've never seen before. The universe is full of surprises, after all. But while these fringe theories spark imagination, they often crumble under scientific scrutiny. The truth is, extraordinary claims require extraordinary evidence, and so far, Oumuamua hasn't handed us any smoking guns. Still, the fact that we're even having these debates shows just how puzzling this object really is. Whether it's a cosmic fossil or something even stranger, Oumuamua has left us with more questions than answers, and that's what makes it so fascinating. Up next, we'll compare Oumuamua to its interstellar sibling, 2I Borisov, and see why this second visitor was far less mysterious, but no less important. Now, let's turn our attention to the second known visitor from beyond our solar system, 2I Borisov. Unlike Oumuamua, this interstellar traveler was far less mysterious, behaving exactly how scientists expected a comet to behave. The differences between these two objects couldn't be more striking, and they teach us something important about just how unusual Oumuamua really was. When 2I Borisov arrived in 2019, it looked like a textbook comet, bright, fuzzy, and trailing a long tail of gas and dust. Telescopes around the world had no trouble spotting it, and its composition matched what we've seen in comets from our own solar system. It was made of ice, rock, and organic compounds, and as it neared the sun, it released plumes of material in a predictable way. In other words, it was exactly what astronomers had imagined an interstellar comet would look like. But that's what makes Oumuamua so baffling. While 2I Borisov fit neatly into existing scientific models, Oumuamua defied them at every turn. No visible tail, no outgassing clouds, and that bizarre, elongated shape, nothing about it matched our expectations. Even its acceleration didn't behave like a typical comet's. If 2I Borisov was a familiar guest following the rules, Oumuamua was the wild card that broke them all. So why the stark contrast? One possibility is that Oumuamua represents a completely different class of interstellar object, something rare, or even unique, that we just haven't encountered before. Maybe it's a fragment from a shattered planet, or a type of cosmic iceberg made of exotic materials, or, as some still speculate, could it be something artificial? Whatever the case, the fact that 2I Borisov was so ordinary only deepens the mystery of Oumuamua's strangeness. What's clear is that interstellar visitors aren't all the same. Some, like 2I Borisov, remind us that the universe follows familiar patterns. Others, like Oumuamua, challenge everything we think we know, and that's the real lesson here. Space still has surprises in store, and the next visitor could rewrite the rules all over again. Up next, we'll explore how the public's fascination with Oumuamua sometimes clashed with the cautious world of science, and what that tells us about how we interpret the unknown. Now, let's shift gears and talk about how Oumuamua became more than just a scientific curiosity. It turned into a cultural phenomenon. While astronomers were carefully debating its origins, the rest of the world latched onto a far more sensational idea. Was this our first confirmed piece of alien technology? The media played a huge role in shaping this narrative. Headlines screamed about mysterious alien probes and interstellar spies, even though most scientists were far more reserved. Avi Loeb's light sail hypothesis, while scientifically grounded, got twisted into clickbait that overshadowed the quieter, but more likely, natural explanations. Social media amplified the noise, with conspiracy theories spreading faster than the facts. Suddenly, Oumuamua wasn't just an odd space rock, it was proof of extraterrestrial life, at least in the public imagination. But here's the problem. Science doesn't move at the speed of viral tweets. Researchers needed time to gather data, test hypotheses, and debate. By the time they reached cautious conclusions, the alien narrative had already taken root. This disconnect between excitement and evidence isn't new. Think of the face on Mars or the wow signal. But Oumuamua's case highlights how easily complex science gets simplified or even misrepresented in the public eye. So what can we learn from this? First, that scientists and journalists need to work together better. Clear, accurate communication matters, especially when the stakes feel high. Second, as audiences, we should stay curious but critical. Not every mystery is a sign of aliens, and that's okay because the real story, the one about how weird and wonderful the universe truly is exciting enough on its own. Next, we'll dive into how Oumuamua has reshaped the search for extraterrestrial intelligence and what new clues astronomers are hunting for in the cosmos. Now, let's widen the lens and explore how Oumuamua fits into the bigger picture of hunting for extraterrestrial intelligence. While the debate over its origins continues, this mysterious object has undeniably sharpened the focus on what scientists call technosignatures, clues that could hint at advanced alien civilizations. So, what exactly are technosignatures? Think of them as cosmic breadcrumbs left behind by intelligent life. Unlike traditional biosignatures, which might include things like oxygen or methane in a planet's atmosphere, technosignatures point to technology. They could be radio signals, laser pulses, megastructures like Dyson spheres, or even objects like Oumuamua, if they behave in ways natural phenomena can't easily explain. Oumuamua's peculiar acceleration and shape made it a prime candidate for scrutiny. projects like Breakthrough listen, train their instruments on it, searching for artificial radio emissions. They found nothing, but that silence doesn't rule out future detections. After all, if Oumuamua were a probe, it might have been inactive or designed to avoid detection. The real lesson here is that we need better tools and strategies to spot these subtle hints. Moving forward, astronomers are refining their search. Instead of just listening for radio waves, they're looking for other telltale signs, unnatural light patterns, unusual heat signatures, or objects moving in ways that defy gravity alone. Some even suggest scanning for waste heat from advanced civilizations or monitoring for self-replicating probes, which might be scattered across the galaxy. The challenge, of course, is distinguishing alien tech from natural oddities. Oumuamua taught us that the universe is full of surprises, and not every anomaly is a smoking gun. But each discovery pushes us closer to answering humanity's oldest question: are we alone? Up next, we'll imagine the missions that could one day chase down objects like Oumuamua, and the cutting-edge technology that might finally crack their secrets. Now, let's turn our gaze to the future, because if we want real answers about objects like Oumuamua, we'll need to do more than watch them zip past. We'll need to chase them. Picture this: a spacecraft, purpose-built to intercept the next interstellar visitor. NASA and the European Space Agency have already sketched out ambitious concepts for missions like these. One idea: the Comet Interceptor, set to launch in 2029. It won't target a specific object, but will instead park itself in space, lying in wait for the next Oumuamua-like passerby. Once spotted, it would spring into action, racing to meet the object and study it up close. But catching up to something as fast as Oumuamua isn't easy. Traditional chemical rockets just won't cut it. That's where advanced propulsion comes in. Imagine nuclear, thermal, or electric propulsion systems, technologies that could slash travel time by harnessing the immense energy of nuclear reactions or ionized particles. Some proposals even lean on solar sails, using the gentle but relentless push of sunlight to accelerate over years, much like a cosmic surfboard riding photon waves. Then there's the question of what to send. A bulky, human-operated probe? Probably not. Instead, think lightweight, AI-driven scouts. These could be tiny, hyper-efficient spacecraft equipped with smart sensors, capable of making real-time decisions without waiting for signals from Earth. They'd need to be tough, too able to endure decades in the void and still snap crystal-clear images or sample an object's composition on the fly. The stakes are high, but so are the rewards. A successful intercept could finally reveal whether objects like Oumuamua are natural oddities or something far more intriguing. And with projects like Breakthrough Starshot pushing the boundaries of miniaturized, laser-propelled probes, the dream of reaching an interstellar visitor might not be so distant after all. Up next, we'll tackle the biggest unanswered questions Oumuamua left behind, and why some mysteries might linger for generations. Even with all we've uncovered, Oumuamua still holds onto its secrets tightly. Let's dive into the biggest questions that keep scientists up at night, the puzzles that, if solved, could rewrite what we know about interstellar visitors. First, there's the mystery of its shape. Telescopes caught only fleeting glimpses, but what they saw was bizarre, an object stretched out like a cosmic cigar, unlike any asteroid or comet we've seen. Was it truly that elongated, or could our limited view have distorted its appearance? Without a closer look, we're left guessing whether this was a shattered shard from a planetary collision or something far stranger. Then there's the question of what it was made of. Oumuamua's dark, reddish hue hinted at organic compounds, but its surface didn't behave like typical space rock. It lacked the telltale coma or tail of a comet, yet it accelerated as if propelled by hidden forces. Some theorize it was a hydrogen iceberg, a fragile chunk of frozen gas that could explain its odd movement. Others wonder if its composition held exotic materials we've never encountered. That brings us to its most baffling trait, the acceleration itself. Outgassing, the usual suspect for such movement, would have left visible debris, but Oumuamua showed none. Could solar radiation pressure have pushed it, as Avi Loeb's light sail theory suggests, or was there another, entirely unknown mechanism at play? The absence of a clear answer leaves room for both groundbreaking science and wild speculation. And perhaps the most frustrating question of all, will we ever know for sure? Oumuamua is now beyond our reach, fading into the darkness with its secrets intact. Future visitors might hold clues, but unless we're prepared to chase them down, these mysteries could linger indefinitely. What's undeniable is how Oumuamua has humbled us. It's a reminder that the universe still has stories to tell, and some of them might defy explanation for years to come. Up next, we'll wrap up this cosmic detective story by asking what Oumuamua teaches us about embracing the unknown. So where does this leave us in the great Oumuamua debate? Whether you're Team Spycraft or Team Galactic Fossil, one thing is certain. This strange visitor from the stars has shaken up our understanding of the cosmos. The truth is, we may never get definitive answers about what Oumuamua truly was, and that's okay. Some of science's greatest breakthroughs start with mysteries that refuse easy explanations. Think about it. Just a century ago, we didn't know galaxies existed beyond our own. The idea of interstellar objects passing through our solar system was pure science fiction. Now, thanks to Oumuamua, we're having serious conversations about how to study these cosmic nomads, how they might form, and yes, whether some could be more than just space rocks. That's progress, even if it comes with unanswered questions. Here's the beautiful part: Oumuamua isn't just a puzzle. It's an invitation to build better telescopes, to design missions that could chase down the next interstellar visitor, to keep pushing the boundaries of what we know. Because the universe isn't done surprising us. For every mystery we solve, like why Oumuamua accelerated without visible outgassing, a dozen new questions emerge. That's why this story matters, whether you're a scientist or just someone who looks up at the night sky with wonder. Oumuamua reminds us that curiosity is our greatest tool. It's what turns "we don't know" into "let's find out." So stay curious, support space exploration, and who knows, maybe you'll be around when we finally crack the case of the next interstellar oddball. Until then, keep looking up. The universe has plenty more stories to tell. If you enjoyed this cosmic detective story, don't forget to hit that like button and subscribe for more deep dives into space's greatest mysteries. Ring the bell so you won't miss our next adventure among the stars, and drop a comment below. Do you think Oumuamua was alien tech, a cosmic fossil, or something even weirder? Let's keep the conversation going. The truth is out there, we just have to keep searching for it. Now, let's turn our gaze to the future, because Oumuamua was just the beginning. The universe is vast, and interstellar visitors like it are likely far more common than we once thought. With advanced telescopes like the upcoming Vera Rubin Observatory coming online, astronomers are gearing up to spot more of these cosmic travelers. Imagine what we could learn if we catch the next one early enough to study it in detail. And here's the exciting part: You don't have to be a scientist to join the hunt. Citizen science projects like NAS, A Backyard Worlds, and the Zooniverse platform let everyday stargazers help scan the skies for strange objects. Who knows? The next Oumuamua might be discovered by someone just like you, sitting at their computer and sifting through telescope data. The search for interstellar objects is heating up, and with each new discovery, we'll get closer to unraveling their secrets. Will the next visitor be another silent, mysterious traveler like Oumuamua? Or will it be a comet-like spectacle like Borisov? Or dare we say it, could it finally be something that defies all natural explanations? So what do you think? Was Oumuamua a one-of-a-kind cosmic fluke, or a hint of something even bigger lurking in the depths of space? Drop your theories in the comments below: alien tech, space fossils, or something no one's even imagined yet. The universe is full of surprises, and the next big discovery could be just around the corner. If you're as fascinated by these interstellar mysteries as we are, make sure to subscribe and hit the notification bell so you don't miss our next deep dive into the unknown. The stars have so much more to show us. Let's uncover their secrets together.